Okay, so concept two will be the calculation of the speed of sound. So of course we know that sound travel faster in solid and slower in gas, right? So for example, the speed of sound in solid, right, is roughly 5,000 meter per second, whereas for speed of sound in air is roughly 330 meter per second. So why is that so? Remember under the kinetic model, right, we know that for solid, the particles are very closely packed together. So example, if I have a sound wave and this sound wave is going to disturb the very first particle right here. So the first particle will of course vibrate in parallel to the wave travel and collide with the second particle right here. So the second particle is going to collide with the third particle right here. So the collision is actually quite fast because they are very close together. Whereas for air, right, the air particles, for example, if I have a sound wave, so this sound wave is going to cause the so-called oscillation of this first particle. But it is very hard to disturb the so-called neighboring particle right here because it's very far apart. So since they are very far apart, it's very difficult to collide, right? The speed of sound in air is actually the slowest, right? So as a rule of thumb, the speed of sound actually depends on how easy the particles are able to collide with one another, right? Okay, so how do we measure the speed of sound? So there are two methods lah. So I will introduce the first method first. So the first method is what we call the direct method. So what's the direct method? So direct method, let me just go here. Okay, direct method, imagine we have two person. So one is the gunman, one is the timer, right? So we keep them at some distance apart, and this distance to make the speed of, to calculate the speed of sound to be as accurate as possible, the distance must be as large as possible. So for example, let's just say make our separation to be 500 meter. Okay, so the person A will fire the pistol, and since we know that the speed of light, right, is the fastest, so it's about 3 times 10 to the power of 8 meter per second, the timer will start the stopwatch. So when the timer, when a person, so this person right here hears the sound of the gunshot, right, he will stop the stopwatch. So since we know that, oh, the sound travel 500 meter in this timing, right, so this will this is how we calculate the speed of sound. So you just need to use speed equal to distance divided by time. So what is the distance traveled by the sound? So the distance traveled by the sound is 500 meter. So what is the time? The time is the between the, you know, the seeing of light from gun and hearing of gunshot. So that is the time that we are talking about, right? So that is how you calculate the speed of sound using the direct method. Of course, for direct method there is a bit of error. So what are some of the errors? So for example, some of the errors might be the wind effect. So wind might cause the speed of sound to deviate from the theoretical value of the speed of sound. So how do we minimize that? We can exchange the position of person A and B and then repeat the experiment. So this will actually reduce the effect of wind. Of course, the second is to repeat the experiment several times and take the average value of time intervals. So that is how we measure the speed of sound using the direct method.